I'm going to try and do a stop action animation on this problem. Let's see what happens. Here I am after 1 second. So this ball's in circular motion, and here it is at the second. So I'm going to show you every second. Let's say let's say it goes 18 degrees a second. So that's the omega, not in terms of radians per second, but that's the omega. Because I want to go all the way around in 20 seconds. So it means I go 18 degrees per second. So this graph is showing the y position at any time, or at the 1 second, 2 second, 3 second, 4 second, 5 second. Okay. So here's where it is at the 3rd second. And here's the 4th second. So notice how it's laying out over on the left side on the circle. Every second the theta is the same. Theta 1, theta 2, theta 3, theta 4. They're all 18 degrees. But over here on the y versus t axis, the amount of height I'm gaining is changing with every second. Here I gain the same angle each second. My omega is constant, but the amount of height I'm getting each time is changing. Okay, it's getting less and less because as I'm curving around, I'm getting less and less height for every second. Okay, now let's do the 5th second. So here's the 5th second. I've reached the highest point, and notice now the delta y is getting less and less, and so it's curved back around to 0. So if I connect these up, in right here, these points, and let's say an orange pin, then I get the first part of my graph. It's not parabolic. It looks parabolic, but it's not. We'll keep going. So I added what's going on. So I'm showing you up here what's going on in the in the y. I was showing you step by step. But I added on what's happening in the x projection. So all I'm doing is I'm projecting this point. Is this going in circular motion, uniform circular motion, simple harmonic motion? Okay, uniform circular motion, as it goes counterclockwise, say 18 degrees a second. Okay, that's its omega, not in terms of radians per second, but that's its omega. 18 degrees a second. If I shine a light, if I have a light source over here, and I'm shining it on there, and all I do is I'm looking at the shadow, the verticality of the dot. That's what this graph is measuring. How vertical, how high up is it getting each time? This graph down here, this x, is measuring how the horizontality of it. How horizontal did it move? It started here. That's the opening position. And so you see the first step, if I project the horizontalness of it, it's right there. If I project the horizontalness of the next one, it's right there. So, yeah, so it's like where is the position at the first second? Where is it vertically and where is it horizontally? Same as where is it vertically, where is it horizontally? All right, so that's what I'm going to do. I'm going to time lapse this and plot all the rest of the y and all the rest of the x. So every time I do it to stop action, I'll do it for every 1 second. Okay, here's the next second. Okay, I'll do it every second. Here's the next second. Here's the next second. Okay, now I know what it feels like to build a roller coaster. Here is the next second, and I feel like I'm building 2 roller coasters here. But notice that we're getting a sine wave. We're starting to get a sine wave here. We're getting a cosine wave here. So both of these are produced at the same time, sine and cosine. And all we're doing is we're doing a vertical projection of the circle of where the ball is along the path, this boss, for the sine wave. Should put a dot right there. And then we're doing a red dot. And then we're doing the horizontal projection down here, and that's giving us the cosine wave. Okay, I'll keep going. And here's the next second. Okay, so there is 1/2 or pi radians for, this is pi radians for the circle, pi radians for the sine wave, and pi radians for the cosine wave. Okay, 180 degrees. All right, so now your job is to finish. You know what this will look like, but look at the dots. Notice how each one of these dots is the same arc length apart, because this is going at a constant velocity. So believe it or not, this represents constant velocity, constant circular velocity, and this represents constant velocity. Okay, just the horizontal projection of that velocity, and here's the vertical projection of that velocity. Okay, so now your job is to complete this.